Hi everyone, this is the third part of my discussions on Polya's problem-solving framework, and my illustration will focus on age problems. And at the end of this lecture, you are expected to be able to solve age problems following the Polya's four-step approach in problem solving. Age problems deal with comparing the ages of people at a particular time or period expressed in year. So in solving age problem, we use strategies such as using a variable to represent an unknown present age, and then we construct a table to represent their ages at a given period. Now, the principles that we use in constructing the equations, one is the time elapsed is equal to the increase or decrease of age. For example, if the present age of A is X, so 3 years from now, A will be X plus 3 years old. Or if B is Y years old now, 4 years ago, B was Y minus 4 years old. Another principle that we used in constructing the equation is that the difference of ages of two persons in two periods are equal. So we construct the table of values. So we have your A and B and the two periods T sub 1 and T sub 2. If in the first period A was P years old and B was Q years old, and in the second period A is X years old and B is Y years old, so the difference of the age of A from the first period to the second period must be the same difference for the age of B from T sub 1 to T sub 2. And so we have X minus P is equal to Y minus Q. Or similarly, the difference of the ages of A and B in the first period must be equal to the difference of their ages in the second period. That is, P minus Q is equal to Q minus Y. So these are the two principles that we will be using in constructing the equations based from the given conditions in the problem. Let us solve this problem. A man is 30 years older than his son. In 10 years, he will be 10 more than twice as old as his son. How old is the son? We start our solution by understanding the problem. So in this problem, we are asked to find the present age of the son. Then we are given a condition that the man is 30 years older than his son. Another condition is that in 10 years, the man will be more than or 10 more than twice as old as his son. So the second step is to devise a plan. Since this is an age problem, we make use of variables to represent the present ages of the sun and the man. So we let x and y be the present age of the sun and the man respectively. And then we are going to construct the table of ages. But first, we have to identify the period when the ages are being compared. So in the first condition, a man is 30 years older than his son, then we are referring in here to the present ages of the man and the son. In the second condition, we're given in here in 10 years. The man will be 10 more than twice as old as his son. So we are referring in here to the future ages of the man and the son. And so we're going to construct the table showing the present and future ages of the son and the man. We are now ready to carry out our plan. That is, we are going to construct the table of ages of the son and the man. Since we are given the number of years in the future when their ages are being compared, we make use of this principle that the time elapsed is equal to the increase of age. So we have here, we have the son and the man, the present age and their future age 10 years from now. So we have let x represent the present age of the sun and y as the present age of man. That means in 10 years or 10 years from now, the sun will be x plus 10 years old and the man will be y plus 10 years old. So we are now ready to write equations based on the given conditions. The first condition is that a man is 30 years older than his son. So in here, we are talking about their present ages. And it says that the man is 30 years older than his son. So y is equal to x plus 30. The second condition is, in 10 years, the man will be 10 more than twice as old as his son. So in here we are talking about their future ages. And it says that this future age of the man is 10 more than twice the age of the sun. So we have y plus 10 is equal to 2 times x plus 10 plus 10. So we are now ready to simplify this equation. We substitute the value of y, which is x plus 30. So we have x plus 30 is equal to 10. Then at the right side, we use distributive property. So we have 2x plus 20, then plus 10. Writing all the terms containing x in the left, so we have x minus 2x and all the constants to the right. 20 plus 10 is 30 and 30 plus 10 is 40. That becomes minus 40 at the right side. Simplifying further, it gives us the value of x is equal to 10. So this is the present age of the sun. Then we substitute the value of x in equation 1 to solve for y. So y is equal to 10 plus 30 or y is equal to 40. That means the present age of the man is 40 years old. Last step of our solution is to look back or to check if the values that we obtained satisfy the conditions. So we have found the value of x equal to 10 and y equal to 40. So x plus 10 is 10 plus 10, that's 20, and y plus 10 is 40 plus 10, or that is equal to 50. We check this one with the conditions given in the problem. The first condition is a man is 30 years older than his son. So we are going to compare in here their present ages. So man is 40 and is it 30 years older than his son. So is it 10 plus 30? So as we simplify, we arrive at an identity that means the first condition is satisfied, that the man is 30 years older than his son. The second condition is in 10 years, the man will be 10 more than twice as old as his son. So we will be looking at their future ages. So it says 50 is 2 times 20 plus 10. So this is the man is 10 years more than twice as old as his son. So as we simplify, we arrive at 50 equal to 50. That means the second condition is also satisfied. So since all the conditions are satisfied, then the values that we obtained are correct. And take note, what is asked in the problem is just the present age of the son. And so therefore, the son is 10 years old. Okay, so I will show you another way of constructing the table of ages. This time, we are going to reflect in the table the relationships of the ages of the son and the man. So we have here the son and the man, their present and future ages 10 years from now. If we let x represent the present age of the son, the first condition states that a man is 30 years older than his son. So if the son is x, that means the present age of the man is x plus 30. And in 10 years, the son will be x plus 10. And it says in that period, in 10 years, the man will be 10 more than twice as old as his son. So the age of the man 10 years from now will be 2 times the age of the son, x plus 10 plus 10. So we have already completed the entries in our table of ages. We are now going to write the equations. So this time, our basis in writing the equation will be the principle that the time elapsed is equal to the increase of age. So here, we are going to consider the age of the man. That the future age of the man minus his present age is equal to 10. So as we remove the grouping symbols, we now have 2x plus 20 plus 10 minus x minus 30 equal to 0. So simplifying, this 20 plus 10 and minus 30 cancels out. In the left member, what is left is x, and that x is equal to 10. That means the present age of the sun is 10 years old. To solve for or to check, to look back whether this value that you obtained, you have to put the values of the entries in the table and try to check that one with the conditions before you accept that indeed the present age of the sun is 10 years old. Let us solve this problem. Jessy is 39 years old. Jessy was twice as old as Belle was when Jessy was as old as Belle is now. How old is Belle? So we understand the problem. How old is Belle? So we are asking here of the present age of Belle. And we are given that Jessy is 39 years old. Also, we're given that Jessy was twice as old as Belle was when Jessy was as old as Belle is now. Okay, so we're going to devise a plan. Since this is an age problem, we use variable to represent the present age of Belle. So we let x be the present age of Belle, and we take note in here that we are referring to the present age and the past age of Jessy and Belle, though there is no mention in here as to how many years in the past their ages were being compared. So we make a table showing the past and the present ages of Jessy and Belle. We are now ready to carry out our plan. That is, we are going to construct the table of ages. So since we are not given the number of years in the past that their ages were being compared, what we are going to show in the table will be the relationship of the ages based on the given conditions. So we have here Belle and Jessy, their past and present ages. We have assumed that the present age of Belle is equal to x, and in one condition in the problem, it says that Jessy is 39 years old. So here we are referring to the present age of Jessy. Another condition is Jessy was twice as old as Belle was when Jessy was as old as Belle is now. So the sentence is quite complex. We have to be able to tell when was that particular period when their ages were being compared. So look at this clause. When Jessy was as old as Belle is now. So we are looking at that period when the age of Jessy is the same as the present age of Belle. So since the present age of Belle is X, so we're looking at that period when Jessy was X years old. And it says that Jessy during that time was twice as old as Belle. That means this age of Jessy is double the age of Belle. Meaning, if Jessy is X years old or was X years old, Belle that time is just 1/2 of X. So since we have already completed the entries in our table, we are now ready to write the equation based on the principle that the difference of ages of two persons in two periods are equal. So we have the present age of Belle minus her past age must be equal to the present age of Jessy minus her past age. Simplifying this equation, it gives us the value of x is equal to 26. The last step of our solution is to look back or to check if this value that we obtained satisfy the conditions or the principles that is used in creating the equation. So we have here x is 26, so 1/2 of 26 is 13. One condition given in the problem is that Jessy was twice as old as Belle was when Jessy was as old as Belle is now. So again, we are referring to the past ages of Belle and Jessy, and it says Jessy who was 26 years old, was twice the age of Belle during that time. So we check if 26 is equal to 2 times 13. So we arrive at 26 equal to 26. We have an identity that means the condition is satisfied. Another condition also on the difference of their ages. The present age of Belle minus the past age of Belle must be equal to the present age of Jessy minus her past age. So we have here 13 is equal to 13. Again, the statement is true. That means it satisfies the conditions. So therefore, we say that the present age of Belle is 26. Let us solve this problem. Yen is twice as old as Ben. 4 times Ben's age 4 years ago is 1 year less than Yen's age 5 years from now. How old is each now? Using the Polya's four-step approach of problem solving, we start with understanding the problem. So in the problem, we are asked of the present ages of Yen and Ben. It is also given that Yen is twice as old as Ben. Another condition is that 4 times Ben's age 4 years ago is 1 year less than Yen's age 5 years from now. So since this is an age problem, we make use of variable to represent the present ages of Yen and Ben. And then we construct a table showing their present ages. And there is a mention in here about their ages 4 years ago and their ages 5 years from now. Okay, so we carry out the plan. We construct the table. We have here Yen and Ben and their present ages. So we let Yen, the present age of Yen be X and the present age of Ben be Y. So 4 years ago, if the present age of Yen is X, so 4 years ago, she was X minus 4. And if the present age of Ben is Y, 4 years ago, he was Y minus 4. Then their ages 5 years from now. If Yen, the present age of Yen is X, 5 years from now, she will be X plus 5. And if the present age of Ben is Y, 5 years from now, he will be Y plus 5. We continue our solution, so we just copied the table that we constructed. Now, we are now ready to construct the equations based from the given conditions. The first condition is Yen is twice as old as Ben. So obviously in this statement, we are referring to the present ages of Yen and Ben. And it says Yen, which is represented by X, is twice as old as Ben. So we have X is equal to 2y. Now, the second condition is that 4 times Ben's age 4 years ago is 1 year less than Yen's age 5 years from now. So this statement is quite complicated, so we have to understand what are those ages referred to in the conditions. So we have here Ben's age 4 years ago. So we look at the table. You try to find out where is that Ben's age 4 years ago. So this is Ben, and these are the ages 4 years ago. So Ben's age 4 years ago is therefore represented by y minus 4. And then we also have in here Ian's age 5 years from now. Again, we go back to the table. We have Ian, and 5 years from now, or 5 years hence, her age is x plus 5. So this is Ian's age 5 years from now. Then we go back to the conditions. 4 times this age of Ben, y minus 4. So we have 4 times y minus 4 is equal to 1 year less than Ian's age 5 years ago. That's x plus 5 minus 1. Okay, so we are now ready to simplify. We remove the grouping symbol using distributive property. So we have 4y minus 16 is equal to x plus 5 minus 1, that is x plus 4. Or we can write this one as 4 minus x is equal to 4 plus 16. That's by addition property or by the transposition. Then we have in here the value of x equal to 2y. We can do substitution. So we have 4y minus x, whose value is 2y, is equal to 4 plus 16 is 20. Okay, so simplifying, 4y minus 2y is 2y, that is equal to 20. By division property, y then is equal to 10. So that means this could be the present age of Ben. So we solve for x by substituting the value of y in equation 1. X is equal to 2 times 10, and that is equal to 20. So this could be the present age of Yen. But before we accept that answer, we have to go to the last step, which is to look back or to check if indeed the values that we obtained satisfy the given conditions. So the first condition is that x is equal to 2y, or you have yen is twice as old as Ben. So since x is 20, we have equal to 2 times 10, we arrive at an identity that means the first condition is satisfied. The second condition is 4 times y minus 4 is equal to x plus 5 minus 1. So as we substitute the value of y and x at the right side, so we obtain in here 4 times 6 is equal to 20, is it equal to 24? So 20 plus 5 minus 1. 24 is equal to 24. We arrive at an identity that means these values of x and y satisfied also the second condition. So we finally say that indeed Yen is 20 years old and Ben is 10 years old. Let us solve this problem. Rona is thrice as old as Lynn was when Rona was as old as Lynn is now. When Lynn is as old as Rona is now, together their age is 72. How old is Lynn? We start our solution by understanding the problem. So in this problem, we are asked of the present age of Lynn. Condition is given that Rona is thrice as old as Lynn was when Rona was as old as Lynn is now. Another condition is that when Lynn is as old as Rona is now, together their age is 72. So the second step is to devise a plan. So since this is an age problem, we use a variable to represent the present ages of Lynn and Rona. So if we let x be the present age of Lynn and y be the present age of Rona, then we're going to construct the table. But first, we need to understand the period of ages referred to in the problem. So in the second condition, there is a mention about their past ages. So we have here when Rona was as old as Lynn. And in the second condition, when Lynn is as old as Rona is now. So here we are referring to the present age of Rona. And we are referring to that period when Lynn will become as old as Rona is now. So there is a mention about the past, present, and future ages, though the number of years are not explicitly given in the problem. So construct a table of the ages showing the past, present, and future ages of Rona and Lynn. We now carry out the plan, so we construct the table of ages showing Lynn and Rona and their past, present, and future ages. So we have used X to represent the present age of Lynn and Y as the present age of Rona. Again, in the problem, there is no mention as to how many years in the past or in the future their ages are being compared. So we make use of the given conditions. The first condition is Rona is thrice as old as Lynn was when Rona was as old as Lynn is now. So this statement is quite complex, so we have to understand when is that particular period that their ages are being compared. So in this clause, when Rona was as old as Lynn is now, we are referring to that particular period when Rona was as old as Lynn is now. So in the table, we have the present age of Lynn is X. So we are referring to the particular period in the past when Rona was X years old. And it says, this age of Rona is thrice as old as Lynn during that time. And so therefore, if Rona is X years old and this is thrice as the age of Lynn, that means in that period, Lynn was one-third of X. The second condition is when Lynn is as old as Rona is now, together their age is 72. So again, this clause is referring to the future age of Lynn when she will be as old as Rona is now. So the present age of Rona is Y. When the time comes that Lynn will be Y years old, in this particular period, the sum of their ages is 72. Therefore, if in the future Lynn will become Y years old, therefore Rona will be 72 minus Y. So having completed all the entries in our table of ages, we are now ready to construct the equations. And in constructing the equation, we make use of the principle that the difference of ages of two persons in two periods are equal. So if we're going to get the difference of the age, the future age of Lynn and her present age, that's Y minus X, that should be equal to 72 minus Y minus Y. So simplifying this equation, collecting similar terms, this can be reduced to the equation 3Y minus X is equal to 72. Let this be our equation 1. So another equation that we can make is again using this same principle. So if we are going to consider the present age and the past age of Rona and Lynn, y minus x must be equal to x minus one-third x. So simplifying this equation, it will give us y is equal to 5/3 of x. So we have now two equations, two unknowns. We can now solve for x and y. If we're going to substitute the value of y in equation 1, that will give us now 3 times y, whose value is 5/3 x, minus x is equal to 72. Simplifying further, x therefore is equal to 18. And when we solve for y, we substitute x in equation 2. We have y therefore is equal to 5/3 of 18, or y is equal to 30. So this can be the possible present age of Lynn and the present age of Rona. We now go to the last step of our solution, which is to look back or to check if the values that we obtained are correct. So we have found the value of x equal to 18, the value of y is equal to 30, and one-third of x is, or one-third of 18 is 6, x is 18, y is 30, and 72 minus 30 is 42. We now go back to the conditions. The first one is Rona is thrice as old as Lynn was when Rona was as old as Lynn is now. So the time when Rona was same age of Lynn today. So Lynn is 18 years old. When Rona was 18, this age of Rona is thrice the age of Lynn, which is correct because Lynn was 6 years old then. And 18 is equal to 3 times 6. So the first condition is satisfied. The second condition is when Lynn is as old as Rona is now, together their age is 72. So Rona is now 30 years old. The time comes when when Lynn is 30 years old, Rona is 42. And it says the sum of their age must be equal to 72. So 30 plus 42 is 72. Therefore, the second condition is also satisfied. We can also check these values using the principles on the age problem, that the difference of ages of two persons in two periods are equal. So if we're going to consider the present and their past ages, the present age of Lynn is 18 minus her past age is 6. It must be equal to the present age of Rona, which is 30, minus her past age, which is 18. So we arrive at an identity, 12 is equal to 12. Therefore, the values in our table of ages satisfy the condition. Or if we're going to consider their future age and their present ages, we have 30 minus 18. It must be equal to 42 minus 30. We arrive again at an identity that 12 is equal to 12. Again, the principal and age problem is satisfied. If we consider their future age and their past age, that means the difference of the future age of Lynn and her past age must be the same with the future age of Rona less its past age. So we have here 30 minus 6 is equal to 42 minus 18. We arrive at 24 is equal to 24. Again, the principle of age problem is satisfied. Or the difference of their ages at particular period must be equal at different periods. That is, 18 minus 6 must be equal to 30 minus 18, and it must be equal to 42 minus 30. So again, we satisfy that principle. So having all the conditions and the principle of age problem satisfied, therefore, the values that we obtain, that is x is equal to 18 and y is equal to 30, are correct. That means the present age of Lynn is 18. I will end up my discussion in here. I hope you can now solve the different age problems. Thank you for watching.